do that. Like f of x equals x plus 2. Have you seen this notation right here? Okay. So if f of x equals x plus 2, what is f of 3? Have you seen that?
Do we have to write this down?
No, you do not right now. I'm just saying what you know. Does anybody know what you would do if you were trying to find the f of 3? Okay. You'd plug in 3, you get 3 plus 2, which would equal 5 for that. Does that ring a bell for anybody? Or okay. All right. So I think most of this is going to be new for you. You may have seen a little bit of it before. So what we'll be talking about today are functions. Okay. And before we start talking about a function, we're first going to talk about a relation. So a relation is a set of ordered pairs. So, for example, here are the ages and grade levels of 5 students. So right now they're just listed in columns. But we could easily make this a set of ordered pairs. We could let one of these be our x, one of these be our y. So you'd probably do, in this case, 6, 1, and 12, 7, 15, 9, 15, 10, and 18, 12. Okay. Have you heard the word domain before? Okay. Have you heard it in math before? Okay. In math, what is it? Don't know. You just heard it. Okay. So your domain in math are your possible x values. And domain can be a really complex idea. We're still talking about domain and calculus and pre-calculus. But we'll start with them looking at simpler examples, obviously, here. So for example, in the past example, your domain is your x values. So your x values are 6, 12, 15, 15, and 18. You do not list a number twice when you list the domain. So to write the domain for this, you're going to do an x and then a bar. And that means x such that x equals 6, 12, 15, 6, 12, 15, 18. Sometimes whenever they list domain, they won't put this x such that x equals. Sometimes it does. It really doesn't matter to me. I'm just doing this here so you've seen it and it doesn't look crazy to you. 18. When writing the domain, do not repeat values. so like for example, that 15 was listed there twice, but we don't write it twice. We just write it the one time. Range is going to be your possible y values. Alright, so for the past example, the range is you would just list all those y values. So you would have y such that y equals, I think I've got my squiggle bracket in the wrong place. I don't think it goes here. I think it goes here. That looks better. Let's put the squiggle bracket there. Probably. So you just list those numbers. In this case, there were no repeated values, but it also for the range, do not repeat values. Alright, so in a relation, your domain is all of your x's, your range is all of your y's. A relation can be what we call a function. A function is a special type of relation where each value in the domain has only one value in the range. Now this is going to sound confusing. I have a method for understanding I will tell you here in a second. So a nut here below this, it's really small. You probably can't read it very well. It says in a function, each x can only have one y. So each x can only be assigned to one y. I think that seems a little confusing. These diagrams we're going to look at next, though, help me understand it a little bit better. So I think that if that definition is a little confusing to you, that hopefully we will clarify that here in a minute. So if you go to the next slide, those numbers did not copy well there, so hopefully you'll be able to see it whenever I write it up here. Actually, let me do this. Let me see here. No, it's not the same. Okay, so this is 3, 4, 2, 6, negative 1, 2, and 4, 6. So what we're going to do is called a mapping diagram. In fact, if you want to put here, the diagrams that we just made were called mapping. I'm telling you before we make them. My notes are a little backwards. Mapping diagrams. So in a mapping diagram, what you're going to do is you're going to put all of the domain in one circle and all of the range in another. do not repeat your values. So, like, for example here, I've got 3 is an x value, 2 is an x value, negative 1 is an x value, and 4 is an x value. You don't have to put them in order. Some students like to put those in order, but you don't have to. Just make sure you don't repeat a value. But there were none repeated there, so we didn't have to. And so in the range column, we're going to write all the y values. So we'll put 4, 6, 2, and then I've got 6 again, but I'm not going to list it again. I'm only going to write it once. So you only write these ones. And then you're just going to draw an arrow connecting the ones that go together. So 3 goes to 4. So we have 3 to 4. 2 and 6 are together. So we draw an arrow there. Negative 1 and 2. Then we also have 4 to 6. Now, I'm going to explain this in a way, sort of like an analogy that helps me to remember this. These are your x's, these are your domains, these are your y's. Okay? If you are born with 2 X chromosomes, are you a boy or a girl? You're a girl. If you're born with an X and a Y, then you are a boy. Okay? Alright, so that's science for you. Everybody gets 1 X from their mother, and then your father is either going to give you an X or a Y, depending, and if he gives you an X, then you're a girl. If he gives you a Y, then you're a boy. And that is how the chromosomes for that work. Have any of you had biology yet? Or have biology? I mean, you wouldn't have had it yet, but have it now. Whenever you get to biology, you'll learn more about that genetic sort of stuff. Yes. Can't happen. Can't happen. There might be some very rare mutations where things like that can occur. I'm not sure, because I know there are some like physical conditions where that sort of thing happens, but it would be very rare. Not something that would happen very often. So for our purposes here, we're going to go with just the XYs. Okay? So if you are an X, you are a girl. And if you are a Y, you're a boy. So I'm not endorsing this. This is just our function rule. Okay? Each girl, each X, can only have 1 boyfriend. So, like in this particular situation, girl number 3 is dating boy number 4. Girl number 2 is dating boy number 6. Girl number negative 1 is dating boy number 2. And girl number 4 is also dating boy number 6. In this particular situation, this is okay. Girls can only have 1 boyfriend, but boys can have more than 1 girlfriend. Okay? I'm not endorsing this personally. It's just how functions work. So polygamy is okay if the boys have multiple wives. But guess what, girls? You cannot have multiple boyfriends. Unfortunately, sometimes society actually is like that, because we're not going to say any of them out loud, but you can think of some of the names that would be called for those girls. But boy number 6 here, you might actually think of positive names to give him for having multiple girlfriends. It's not the way the world should work, but sometimes it does. So, girls, you can only have 1 boyfriend. Boys, you can have as many girlfriends as you would like. Okay? So let's check out. So in this particular situation, this is a function. Okay? This is a function. Once again, not personally endorsing this. I'm just trying to help you remember X's and Y's. Okay? Let's look at example 2 here. We want to know if this relation is a function. So we're going to do the same thing. For our x's, we've got, I know it's hard to read there, you got a negative 10. You've got a negative 5. We got another negative 10, but we're not going to list it because it's already there. And we've got a negative 15. Then we've got a 100, a 20, a 0, and a 200. Now you might notice right away, just because the list of boys is longer than the list of girls, this is probably not going to work out so well. Right? So negative 10 is dating 100. Girl negative 5 is dating boy number 20. Uh-oh. Girl number negative 10 is also dating boy 0. Tell you what we think about her. Negative 15 is dating 200. So in this case, girl number negative 10, this is not appropriate here. So this is not a function. Yeah, we're not going to say anything out loud that we might be thinking about girl number negative 10. But yeah, we're still not going to say it out loud. That might be inappropriate. But this situation cannot happen. Okay? So anytime you see that if you see X value repeated, that means we've got a girl that's got more than one boyfriend there listed. So that's going to be sort of an alarm to you that this is not a function. In real life, I don't have to teach you about one-to-one functions yet, but just for the sake of morality here, real life should be a one-to-one function. And in a one-to-one function, each x has one y and each y has one x. So it would work both ways. All girls can only have one boyfriend and all boys can only have one girlfriend. So real life should be a one-to-one function. But for functions, this is our situation that we have here. So one way that you can figure out if a relation is a function is to make these mapping diagrams, or look through and see, oh, do I have a girl, do I have an x that has more than one y? And if you ever see an x over here on this left-hand side that goes to more than one y value, then that is not a function. Okay? So there's a couple other ways that we can, or another way that we can figure out if something is a function, and that's by looking at the graphs. And it's super easy. So we're going to do the vertical line test, or sometimes I might call this the pencil test. So the vertical line test is where we're going to say if a vertical line touches more than one point on the graph, the relation is not a function. Okay, so let me show you what that looks like. So here we have a relation. We've got these points right here. We're going to graph them on a coordinate plane. So we've got 3, 0. I know they're probably a little fuzzy. You probably can't read them very well, but you got 3, 0. So 3, 0 is right here. You've got negative 2, 1. Negative 2, 1. It's right here. You've got 0, negative 1. Negative 3, 2. And 3, 2. So if we graph these points, what we're going to do is we're going to take a vertical line. I have a vertical line here that I can move. You guys have a vertical line you can move. There's your pencil. And if you pass it through the graph, if you go through the graph, if at any point you have 2 points that touch that line, so like right here, I've got like flashing alarms going off here because I've got 2 points that touch that vertical line, then that tells me that this is not a function. So is the relation a function? No, for that one. So vertical line test, I think, is the easiest, especially if they've already given you the graph, because sometimes they'll already give you the graph. I think it's easier than a mapping diagram to use. So, does your next slide look like this? I hope. Yes, okay, good. Alright, so we'll do the first couple together, and then I'm going to let you guys do the rest of them. So if I look at this first function, or first relation here, I don't have dots. I have solid lines. But that's still okay because the lines are made up of points that touch each other all the way across. So anywhere on this graph, do you see anywhere that touches a vertical line twice or more? Nowhere. Okay? So this one is a function. It would be a yes. Okay? If we look at the next one, do you see anywhere that it touches the vertical line more than once? No. Now, there are some places, like right here, it gets awfully steep. It kind of looks like maybe it touches twice there, but that's just because of our, theoretically, a line has no width. Theoretically, it is a line of points that have no width. I realize we can't actually do that, and showing that on paper, if it had no width, it would not show up. But it's really just because our line right here is a little thicker than our graph, and it's pretty steep. But this would still be a function. Okay? So, you're going to look, if the graph is sort of, still increasing, then that's still a function, even though it might get pretty steep at some point. Unless it's exactly vertical. What about this next one right here? Is this one going to be a function? That is a yes. Okay. What about this one? No. Major red flags here. You got lots of places where you're touching at 2 different places. So this would be a big fat no. Okay? What I want you to do right now is go through the rest of those and put a yes or a no next to them. Is it a function or not a function? Alright. This circle. Yes or no? No. What about this? This is a no. You've got several places like right here and right here. Right here. There's several where you got 2 points. So that one's a no. Alright, what about this one? Alright, where at? This one is a yes. They're so bunched up and they're small and it's a little hard to see. But if you check every single vertical line, there is only 1 point on each one. It's a little small, so it's a little hard to see. The next one's a yes. Okay? No. Yes. This one? Why is this one a no? Oh, is there? There's not supposed to be a dot here. If we take that dot away, let's change our answer. You were not, because it was not blue on yours. Sorry about that. If we take that away, what does that do to our answer? That makes it a yes.
That's your error, Micaiah.
This is a no. If that would have been a test, I would have given it to you. Yeah. Okay. Questions? I think the vertical line test is easy. Do you guys think it is easy? Okay. So, and this is part of our curriculum. So this is some stuff might show up on the exam. Things we got to know. You just got to make sure you remember it. Sometimes those things that take us very little effort to remember, we forget it really easily as well. So you just got to remember it. Okay. So the last part we're going to look at function rules. So function rules is really what we're going to use the most. Identifying functions and non-functions is something that we have to do, but function rules are what we're really going to use a lot of here. Okay, so you can think of a function sort of as like a machine. Yes, you plug in the number and you spit out your output. So your inputs are your x's. That's the number you're putting into your machine. And your output is the number you get out of your machine. And then your rule is like what your machine does. So for example, at my house, there are little plastic toys all over the whole entire house. If anybody wants some plastic toys, I will wait till my children are asleep and I will collect them and I will give them to you. Sometimes I do this. They think I'm a monster, but they're everywhere. So, but at the factory where all those stupid little plastic toys that are covering up my floor were made, they put, let's say the Lego factory. All right, there's lots of different types of Legos that you can have. You could have the somewhat forgiving, like big long sheets. You step on one of those in the middle of the night, you're going to be okay. Then they got the little 2x2s that are pointy on every edge. You get one of that, or even worse, not just the 2x2s, but like the taller 2x2s, the ones that are, you step on one of those in the middle of the night and you may just lose your mind right there. May say some things that you would regret. But at the Lego factory, they got a lot of different colors of plastic. And I've never seen the Lego factory work, but I imagine that they put some red plastic into this machine. They got the machine set up to make the 2x2 Lego. It squirts the plastic in there however it does it. It forms it into the shape, and it spits out a red 2x2 Lego on the other side, right? And the machine makes 2x2 Legos, so when they get done with red, then they might have to clean out the machine, but then they put in the green, and then they make a bunch of 2x2 green Legos, and then they use the same thing, and then they make some blue 2x2 Legos. So they put in plastic, they spit out whatever color it is made. So a function's kind of like that. You're going to put in a number. The rule's going to do the same thing to every number that is there, just like that 2x2 Lego machine makes 2x2 Legos out of whatever you put in there. Have you ever, I wonder if it works kind of the same. Have you seen like the Lego candy? It's awful. It does not taste good, but my children want to buy it when we go to candy stores because it's Legos. So it's kind of sweet tart like, except for not as good as real sweet tarts. But I would I wonder if the machines are the same. Like you put blue candy into the Lego machine, would it spit out? I'm sure it's not the exact same because that would not be. But anyway, so that's how the function machine works. So for example, here's our first example. My function is 3x plus 4. So no matter what number I put into this function, I'm going to do 3 times the number plus 4. That's my rule. That's what I do to everything. So if I input -1, then I put an extra column in this one because I wanted you to see what you're doing. So what you're doing is so I know it's small, you probably can't see it. You've got y equals 3x plus 4. Or sometimes you'll see it written like this. I haven't got to notation yet. Actually, no, it's next. Hold on. I don't need to tell you that yet. Getting ahead of myself. So you're just replacing that x with whatever number you're plugging in. So here we're doing 3 times -1 plus 4. So 3 times -1 is -3. And if we add 4, we'll get 1. Here, we're going to do 3 times 1 plus 4. Notice how everything's always the same except for this just number where the x was at is changing. So 3 times 1 plus 4, that's going to give you 7. Then for the next one, to plug in 2, we do 3 times 2 plus 4. Okay, 3 times 2 plus 4, 3 times 2 is 6. 6 plus 4 is 10. And then 3 times 3 plus 4. And so that's going to give you 13. And now those I just chose some numbers for you. You could plug anything in. I could put like 50 if I wanted to. If I want to make another column here, I'd do 3 times 50 plus 4, and you'd get 154. Impressive quick math there, Malia. So you could plug in any number. You don't have to use whole numbers. You could use decimals. You could use fractions. You could plug in any number in the world, and it's going to spit out an answer. Okay? So that is your function machine. Your machine says, it gets this number. It says, oh, look, we've got a -1. We're going to multiply it by 3, add 4. Oh, look, here's a 1. We're going to multiply it by 3, add 4. It's just like a machine that's pumping out the same thing every time. So, the notation that we're going to use here, and this copied really small, is, I'll write it up here. It's a lot of times instead of saying y equals, we're going to say f of x equals 3x plus 4. So it is kind of its replacement. And so you really, really don't see the value of using function notation, possibly not even in this class, maybe a little bit. There is a lot of value in using f of x instead of using y. Just for one thing is it doesn't have to be a f. It could be a G or a K or a C. You'll see that here. It's pretty small. I don't know if you can read it, but you could use any letter. So we might have two different rules that we're trying to compare. We might have one rule is 3x plus 4. We might have another rule that is x squared minus 7. And so we might be trying to compare those two. So we could call one of them f of x and one of them g of x, and then we can talk about the differences more clearly by using the f and the g. Because if they're both y equals, then it's harder to keep them straight. So we're going to see this notation. For a lot of purposes, you can just think of it as being the y, because it pretty much is the y. But as you get to more advanced levels, you're going to see how that function notation means a little bit more. So here's what some problems are going to look like that you're going to see. You're going to see stuff like, for example, one here, it says evaluate f of x equals x squared for x equals 2. And so what we would do there, if we're evaluating this equation for x equals 2, we would say f of 2 equals 2 squared. I'd basically just take, I know it's small, you can't see it. You had that f of x equals x squared. You basically just take your x's and you replace them. This right here does nothing, okay? This is just reminding you that you plugged 2 into f. So you don't mess with this. This is not f times 2. It is not, put that phone in your book bag right now, Zena. It better be up here in the calculator spot tomorrow, or it's mine. Okay. All right. So we don't do anything with this. This just reminds us we plug 2 into F. We don't do anything with it. We just evaluate this part over here, and 2 squared equals 4. So that's our answer. We get 4 for our answer. Okay, the next one says evaluate 3 minus x for negative 3. This can be a little confusing. So you've got, I know you can't see it very well. I'm going to do it this way to make sure it's really clear. I just put the x right there for right now. And so what you're doing when you plug this in is you are replacing the x and only the x with negative 3. So I'm going to put a negative 3 here, and I'm going to put parentheses around it, negative 3 here. Well, good gracious. There we go. Okay, so notice how I did not get rid of that negative. It stayed there. Sometimes it's really easy to lose that. Again, this does nothing. This is just reminding us we plugged in negative 3 into the f function. So we don't do anything over there. Over here, we're just going to say, oh, what do I do when I've got 3 minus negative 3? Got to be a plus on both of those. What do I get, Aiden? 6. That's your answer. Yeah. You do not do anything with that box. That just reminds you what you were plugging in into which function. So you don't do anything with it. All right, the next equation is f of x equals 2x minus 3 plus x. This one has more than one x. We could combine them if we wanted to before we begin, but I believe I will just erase all of my x's, and I'm going to replace them.
You write it down. We write it down and we have to erase.
You don't have to do it my way.
Well, I don't know if I'm
I'm just replacing all those x's with 5s. Okay? And all of the x's have to be replaced with 5s, not just one of them. Okay? So, again, this part, box it up, don't touch it. You don't mess with that stuff. It's not f times 2, it's just reminding you, you plugged 5 into the f function. Hello? Okay, thank you. Bye. Let's see, Hayden. You're leaving. Let me give you. Okay, so for this one, you got a little more work. You got to remember those order of operations a little bit. You got to do 2 times 5 is 10 minus 3 plus 5. So go left to right at this point. 10 minus 3 is 7 plus 5, and 7 plus 5 is 12. Okay, you just do your order of operations. Okay. Okay, questions? All right, this problem over here that was actually, it was the second example too, because I numbered it like I didn't have any sense. So if we look over here, this one's a little bit different. It tells you g of x equals 2x plus 3. And the domain of the function is -1, 0, and 2. Find the range. Remind me, domain. Was that X or Y values? It was my X values, right? So really what they've done here is they've given you 3 X's that you've got to plug in. So all of these are your X values. So you would have to find G of -1, which would be 2. Instead of X, I'm going to write -1. I don't know why it's doing this. Let me see if I can get it to quit. 2 times -1 plus 3, because our rule is 2x plus 3. And so 2 times -1 is -2 plus 3. That's going to give us 1. Then we would have to find G of 0, which would be 2 times 0 plus 3. 2 times 0 is 0 plus 3. And so 0 plus 3 is just 3. And then we've got G of 2. So we would have 2 times 2 plus 3. And so 2 times 2 is 4 plus 3 is 7. So your Y values are your outputs here. So the 3 Y values we just came up with were 1, 3, and 7. So we would write our range as 1, 3, and 7. Okay, questions? Alright, we are skipping the graphs. We're not going to do those right now. We're going to skip the word problems from right now. I do want to show you one more thing. Like, sometimes they might not say evaluate. So, let's say I have G of X equals X squared minus 2. And let's say I have H of X equals 4 minus X. Okay? Sometimes they will not ask you to evaluate. Sometimes they'll just write this. Like for example 1, they might say G G of 4 equals. So, what's that tell you to do? Tristan, what does it tell us to do when we see G of 4? 4 in for all the x's in which function here? Because I've got 2. The first one, because it's a G, right? So I would do 4 squared minus 2. So 4 squared is 16 minus 2, I'd get 14. That's my answer there. Okay. Then you might see something real crazy like this. G of 1 plus H of 2. Ooh. Olivia, what would we do on this one? What does G of 1 tell me to do? What? Not to multiply by 1 here because it looks like multiplication, right? But this is really function notation. So like here, G of 4 told us to plug 4 into this equation. So G of 1 is going to tell us to plug 1 into that equation. So we would do 1 squared minus 2 for that part. But we also have plus H of 2. So Julie, what does H of 2 tell us to do? Okay, so G of 1 told us to take 1. We do not, because that is equation G, right? This one doesn't say G of 2, but H of 2. So we'll use this equation right here, right? So we'll have 4 minus, and then instead of X, we'll put our 2 there. So this part right here, this was your G of 1. and this part right here, that's your h of 2. So then we can figure that out. So 1 squared is 1 minus 2 plus 4 minus 2 is 2. So you got 1 minus 2 plus 2. What do you get whenever you do that? No?
It'd be a positive 1.
1. Because 1 minus 2 is negative 1. Negative 1 plus 2 is 2. Or just like, you could put these two together. Negative 2 and 1, positive 2, they cancel each other out. You just left the 1 right there. Okay. All right, so